Hello, so here I found a rare problem, Olympiad Quebec 1962, an old problem. So this is for series. Um, we have the multiplication of the previous items plus 1 equal the current item. For example, U2 equal U1 times U0 plus 1, 2 times 3 plus 1. U3 equal U2 times U1 times U0 plus 1. And we have the generalization UN equal 2 times 3 times 7, etc. until UN minus 1 plus 1. So the question is to demonstrate that UN plus 1 equal UN square minus UN plus 1. And the second one is knowing that we have the inverse series, like 1 divided by 2 plus 1 divided by 3 plus 1 divided by 7 is equal to 1 minus 1 divided by 42. We're trying to generalize this equation in form of n and prove it by recurrence. So here we can see, we can generalize this equation. Here we can see that we have 1 divided by U0 plus 1 divided by U1 plus 1 divided by U2 is equal to 1 minus 1 divided by 42. 42 is 43 minus 1, which is U3 minus 1. So we can say that 1 divided by 2 plus 1 divided by 3 plus 1 divided by 7 plus, etc. Plus 1 divided by n minus 1 is equal to 1 minus 1 divided by UN minus 1 divided UN plus 1 minus 1, sorry. 42 is 43 minus 1. So this one should be UN minus 1. So this is the generalization of the this equation. We should prove it later on. So let's start with the first one, UN plus 1 equal UN square minus UN plus 1. We try to prove it. So we have this, the first one is what we have, UN equal 2 times 3 times UN minus 1 plus 1. So UN plus 1 is equal to 2 times 3 times 7 times UN minus 1 times UN plus 1. This is by definition. So this one right here, U2 times 3 until UN minus 1 is exactly, if we go to the first one, we can write it down as UN minus 1. If we move the 1 to the other side, so we have UN minus 1 equal 2 times 3 times 7 times UN minus 1. So this one is UN minus 1. So this equal to UN minus 1 times UN plus 1, which is equal to UN square minus UN plus 1. This is the proof for this equation. So the second problem is to prove the generalization that we have 1 divided by 2 plus 1 divided by 3 plus 1 divided by 7, etc. until 1 divided by n equal 1 minus 1 divided by UN plus 1 minus 1. So here we should prove it by recurrence. So we have for n equal, sorry about that, let's see, n equal 1, U1 equal 2, right? So we have 1 divided by 2 is equal to 1 minus 1 divided by U2, U2 equal 3. So 3 minus 1, which is equal to 1 minus 1 divided by 2, which is equal to 1 divided by 2. So this is correct for n equal 1. We suppose that for n, this one is correct. So we should prove that the equation for n plus 1 is correct. So for the n plus 1, we have 1 divided by 2, plus 1 divided by 3, plus 1 divided by 7, plus 1 divided by un, plus 1 divided by un plus 1. This one is equal to 1 minus 1 divided by un plus 2 minus 1. This is what we should demonstrate, right? Plus 2 minus 1. So 1 divided by 2 plus 1 divided by 3 plus 1 divided by 7 plus 1 divided by un plus 1 divided by un plus 1 is equal to this one is 1 minus 1 divided by un plus 1 minus 1 plus 1 divided by un plus 1. Okay, so this is, we just replace the first equation with that is correct for n in here, and we add the 1 divided by un plus 1. So here this is equal to 1. If we put un plus 1 times un plus 1 minus 1, we'll have un plus 1 minus un plus 1 minus 1, because minus times minus is equal to plus, to positive. And this one is equal to 1 minus un plus 1 minus un plus 1 minus 1. So this is equal to 1 divided by un plus 1 square minus un plus 1. So this one, if we go to the previous proof that we have, we know that un plus 2 is equal to un plus 1 square minus un plus 1 plus 1. If I'm not mistaken, let's go back. So un plus 2 for the proof A is equal to un plus 1 square minus un plus 1 plus 1. Okay, so we just replace. This one is equal to un plus 1 square minus un plus 1 is equal to, this one is equal to 1 minus 1 divided by un plus 2 minus 1. So we prove it for n plus 1 that we have this is correct. For n equal 1 is correct. We suppose that for n is the equation is correct, and we prove it for n plus 1. So this is the solution for this problem. Hope you find it interesting. Thank you.